For many manufacturers, the real cost of production quality can be more than 15% of sales revenue. Let's follow the quality control transformation and business impact across 3 manufacturing plants as they deploy AI at scale with Google Cloud's Visual Inspection AI solution. A semiconductor fab in Taiwan is looking to improve their silicon wafer and semiconductor chip yields by detecting defects at the source and reducing waste to meet their increased production targets. Chen, a production yield engineer, is taking the first steps to automate the defect detection with the Visual Inspection AI solution. He first collects images of the wafers and imports them into a Visual Inspection AI dataset. He then creates labels for the type of defects, such as scratches and discoloration. The simple user interface helps him quickly annotate defect areas on the images. Unlike other solutions, he only needs to annotate 10 images for each defect type. That's enough for the Visual Inspection AI model to start its training. After the training is done, Chen reviews the model's performance against key metrics like precision and recall. To deploy the inspection model, he exports it to a Docker container by creating a solution artifact. Once deployed, the model can run either autonomously on premises or in the cloud. It can also be deployed at scale across multiple fabs. For most fabrication plants, the total avoidable cost of production quality issues can easily reach $55 million per year. The semiconductor chips from the fab are shipped up the supply chain to an electronics contract manufacturer in Mexico. The manufacturer makes printed circuit boards for a variety of customers and is focused on improving production yields by reducing rework and scrap. Maria is a manufacturing engineer implementing the visual inspection solution across multiple PCB assembly lines in their factory. She selects one of the uploaded PCB images as a template image and defines inspection areas and individual components using bounding boxes. The Visual Inspection AI solution then automatically localizes and crops component areas for all imported images. Maria previews how the component detection and cropping will be applied. If it looks right, she simply clicks Apply to All. She then trains AI models for each of the components on the assembly board. Visual Inspection AI provides active learning, which intelligently surfaces suspect images for Maria to label. She labels a few normal and abnormal images, and the assembly detection model retrains itself. Maria can review the model performance for each component and see the precision, recall, escape rate, and overkill rate. For a typical electronics manufacturing factory, the total avoidable cost from production quality issues can easily reach $23 million per year. Finally, the inspected circuit boards are supplied to an automotive assembly plant in the US. Let's zoom into the manufacturing floor and see their paint operations. Jeff is the quality assurance manager at the plant and has successfully implemented a model to detect paint scratches in car doors. He now wants to detect a new type of defect, orange peel texture variation. In the user interface, he simply adds a new defect type for orange peel. Jeff imports a few training images for this defect type. And as before, he annotates the location of the defects. After clicking the Start Training button, he now has an updated model that can accurately detect this defect type. The visual inspection solution can be applied to their welding and other operations. From an operations dashboard, the plant manager is able to view the quality performance and receive notifications from the various production lines. For an average automotive plant, the total avoidable cost from production quality issues can easily reach $50 million per year. What will visual inspection AI do for your transformation?